Hello mathematicians, thank you for joining me today as we try to find the derivative of this function x squared plus 2x times sine of x plus 5 all over 3x plus 2. So now as we look at this, I would try to simplify if I can, but I believe this is simplified already for us. So what I want to do next is say, okay, if I'm going to take the derivative, what's the first thing that catches my eye? What's the broad overview picture that's going on? And so if I look at this, the first thing I see is this big line going across the middle. It seems to be the largest portion of my function. And so that line means divide. So I have a division or a quotient of two functions. And because I'm trying to take the derivative of a quotient, I have to use my quotient rule. So I'm going to remind myself of what the quotient rule is. And that is if I take the derivative of the top over the bottom, I get bottom d top minus top d bottom all over bottom squared. Now again, I'm using the song to kind of memorize what these are. And I go bottom d top minus top d bottom all over bottom squared. Notice the low notes for bottom, the high notes for top. When I did the product rule, you'll notice I used the same pattern. Second d first plus first d second. And the reason why I do it in that order is because now it lines up. Bottom d top minus top d bottom. And where I'm thinking of the top as the first and the bottom as the second, so I can keep my order straight so that I know I have to subtract the top times the bottom prime. While the order isn't important for the product rule, it is important for the quotient rule. And that's why I'm keeping those in that order as I'm trying to memorize these. Now that we've recalled the quotient rule, the next thing we need to do is say, okay, well, if we have a quotient rule, we have to find our top, we have to find our bottom. And so our top function is x squared plus 2x times sine of x plus 5. Our bottom function is 3x plus 2. And our top prime is, now if I look at this, it's not immediately clear to me what the derivative is going to be. So instead of trying to figure it out right now, I'm just going to say, let's put a question mark here, and we'll figure that out as a separate problem and bring it back when we're done. So if I skip that one, I go to the bottom, prime is 3. And so now the point here is that in order to figure out this derivative, the only thing I really have to find now is the derivative of the top. And so if I can find that, I can plug that all in back here. So we'll go ahead and just find the derivative of the top. All right, so as we continue, we wanted to find the derivative of the top, which was this function. So now, if I look at this function, I have a new problem. And I'd say, okay, big picture, what's going on here? And the big picture is that I have this function times this function, so I have the product of functions. Therefore, if I want to find the derivative, I have to use the product rule. And the product rule was the derivative of the first times the second was second d first plus first d second. So now if I use that, I just have to find my first, my second, the derivative of the first, and the derivative of the second. So now the first function is x squared plus 2x. The second function is sine of x plus 5. The derivative of the first is 2x plus 2. And the derivative of the second is, well, the derivative of sine is cosine. So I get cosine x, and the derivative of 5 is 0. So the derivative of the second is just cosine x. Now that I have those, what I'm going to do is just plug those in. So I get second is sine of x plus 5 times the derivative of the first is 2x plus 2 plus the first is x squared plus 2x times the derivative of the second is cosine x. So I'm left with the derivative of x squared plus 2x times sine of x plus 5 is indeed just sine of x plus 5 times 2x plus 2 plus x squared plus 2x all times cosine of x. So now what we need to do is we finish this problem. So we go back to our original problem using this as the derivative of the top so that we can use our quotient rule and find the derivative of the whole function. Now that we've figured this all out, I've brought it back together. Remember that this was a quotient rule, so I wrote my quotient rule down so that I have it. I wrote down my top, my bottom, my top prime I brought over from our work, and my bottom prime. Now all I need to do is fill these in. All right, and so because I was going to run out of room here, I erased this, but what I left with is the top is 3x plus 2 times the derivative of the bottom. Copying that from before, we had sine of x plus 5 times 2x plus 2 plus x squared plus 2x times cosine x, minus the top is x squared plus 2x times sine of x plus 5 times the derivative of the bottom is 3, all over the bottom, 3x plus 2 squared. And so that is the derivative of our original function. Notice that there's a lot that's happening here, and if I try to go directly from here to here, it's quite difficult, and it's very likely that I'm going to make a lot of mistakes. So what I did instead was I really did try to take this one step at a time. I focused on things like it's a quotient rule. What's the top? What's the bottom? If the derivative of the top was too difficult to do, I went off to the side and did it as another problem and brought it back when I was done. By doing this way, one step at a time, what it does is it allows me to have the opportunity to make fewer mistakes than I otherwise would, and therefore I'll end up with the correct answer more often. Thank you for joining me today. I hope you learned something and enjoyed the process. If you did, make sure to like the video and subscribe to the channel. It all helps to make sure that we can get this out to anyone else who needs calculus help.